Okay, so welcome back sa ating video lecture. So under Module 8, we have the impulse and momentum. So for this topic, under Session 8, so basahin muna natin yung objective ng Session 8 na to. So in this session, you will get to know more about the concepts of dynamics of rigid bodies and other engineering science. And by the end of this session, you should be able to, so for number 1, to develop the principle of linear impulse and momentum for a particle and apply it to solve problems that involve force, velocity, and time. Okay, so pag ang unknown daw is itong tatlong to. So, it's better to apply the principle of the impulse and momentum. So, kung maaalala before, ano ba yung ano natin? Work and energy. Di ba? Force, distance, at saka yung velocity. So this time, with consideration naman with respect to time. Number 2, to study the conservation of linear momentum for particles. Next, to analyze the mechanics of impact. And last, to introduce the concept of angular impulse and momentum. So for the lecture part, basahin natin, what is the principle of linear impulse and momentum? Under this section, we will integrate the equation of motion. Okay, so integrate the equation of motion, which is the summation of forces equals to mass times acceleration, with respect to time, and thereby obtain the principle of impulse and momentum. So the resulting equation will be useful for solving problems involving the force, ayan nga, the velocity, and time. So using kinematics, the equation of motion for a particle of mass m can be written as, so again, alam natin na yung force is equals to mass times acceleration. And when you solve for acceleration in terms of dv over dt, so ganito yung magiging formula natin. Okay, so where a, the acceleration, and the velocity are both measured from an inertial frame of reference. So when you rearrange the terms and integrate between the limits of the velocity and time with respect to b sub 1 and t sub 1, or its initial velocity and at time 0, or at any time t, and v and t as your final velocity and yung final time na i-consider natin. So with that, we will have an equation of, so anong nangyari nga lang ulit, ito, itinaas mo, or the equation will be f dt is equals to m dv. So by integrating both sides, so again, yung limits mo for time, so this is t1 and t2, and for velocity, that is v1 and then v2. So ito lang din yun. Okay, so if you're going to solve for the velocity in terms of v1 and v2, so ito yung magiging version equation na yan. Okay, so I will just discuss about this formula. So this equation, ayan, as shown in the presentation, so this is referred to as the principle of linear impulse and momentum. So this was derived, or this is from the derivation. It can be seen that it is simply a time integration of the equation of motion. Yung ma natin kanina is equals to the summation ng forces. So it provides a direct means of obtaining the particle's final velocity, or yung v sub 2 natin, after a specified time period when the particle's initial velocity is known. So alam natin yung initial velocity niya, and yung mga forces acting on the particle. So it's either constant or can be expressed as function of time. So yung force mo, again, sabi nga dyan, so it's either constant siya or varying with respect to time. So by comparison, if b sub 2, or the final velocity, was determined using the equation of motion, then a two-step process would be necessary. So apply the summation of force is equals to mass times acceleration to obtain A. And then, after that, integrate A, which is equals to dv over dt, to obtain the velocity 2, or the final velocity. Okay, so what is the linear momentum? Guys, ang linear momentum is itong part ng equation na to. This one. So this is our linear momentum. And then yung right side, guys, ng equation natin. So this is the linear impulse. So kaya tinawag siyang impulse and momentum. Impulse momentum method. Linear impulse. So i-discuss muna natin. What is this linear momentum? So each of the two vectors of the form L, so ito isang variation yan, is equals to, or yung linear momentum natin is equals to mass times the velocity. So in equation 15-2, so ito is referred to as the particle's linear momentum. So yun yan. So since m is a positive scalar, the linear momentum vector has the direction, or has the same direction as the velocity. And its magnitude mv, or the mass times the velocity, has units of mass times velocity, or if you consider the unit in SI, so the units is in kilogram, meter per second, and if that is in English unit, so that will be slug multiplied by feet per second. So anyway, hindi lang naman limited dito, so maaaring kilometers per hour or depende sa unit na ibibigay sa atin. Next one, so we'll now discuss the linear impulse. So the integral I or the impulse, which is I is equals to integral of f dt. So ito nga siya, yung linear impulse natin, is referred to as the linear impulse. So this term is a vector quantity which measures the effect of a force during the time the force acts. Since time is a positive scalar, the impulse acts in the same direction as the force, and its magnitude has a unit of force times time. So if you're going to consider the SI units, so again, that is force times time. So that will be Newton second. And if you're going to consider the English unit, so the unit can be in pound seconds. So again, if it's either second, minutes, are, so depende na lang guys sa units. So if the force is expressed as a excuse me, as a function of time, the impulse can be determined by direct evaluation of the integral. In particular, if the force is constant in both magnitude and direction, the resulting impulse becomes, so kapag constant guys yung force na kino-consider natin, then yung equation ng I instead ng integral yan can be written as yung force, constant force multiplied by T2 minus T1. So para nangyari, ganito lang din siya. Ano? Or that can be Fc T2 minus Fc of T1. Okay? So graphically, the magnitude of the impulse can be represented by the shaded area under the curve of force versus time. So again, under y-axis, this is the force, and at the x, this will be the time. So itong graph na to, ito is under variable force. As you can see, yung force is varying with respect to time. But if it is a constant force, then it will produce a rectangular shape. So hindi nagbabago yung force at any time t. So kaya ganito yung naging itsura ng iyong diagram. Okay, so the principle of impulse and momentum. So what is discussed in this section? So the principle of linear impulse and momentum. So for problem solving, so equation 15-2 will be rewritten in the form. So nangyari guys, inilipat niya lang yung MV1. Ano? Kasi before, ang equation natin is ganito. Ano? Transpose lang niya yung MV1, itong part na to. That's why, kung napansin nyo, naging positive na siya. Or MV1 plus the summation of the impulse. Okay, so ganun lang din naman yan. Ni-arrange niya lang. So this version of the equation, eto. So, This states that the initial momentum of the particle at time t plus the sum of the impulses. So, ayun nga, yung initial momentum, which is yung mv1 natin, stands for the mv1, initial momentum, plus the sum of all the impulses applied to the particle from time t1 to t2. So, which is this one. This is for the impulse applied to a particle at any t1 is equivalent to the final momentum of the particle at time 2. So, is equals lang daw sa final momentum. Ayan. So, dinefine niya lang yung equation na yan. So, again, the sum of the initial momentum plus the summation of the impulse is equals lang sa final momentum. Pero ako guys, I much prefer yung variation ng equation na to. So, ito na lang kasi yung ginagamit ko din. Para at least kamukha lang din ng nauna nating equation for work and energy. Okay? The summation of work, force times distance, to the kinetic energy, yung 1/2 mv squared. Okay, so these three terms are illustrated graphically on the impulse and momentum diagram shown in figure 15-3. So, ito siya. Okay, so where it states that the two momentum diagram are simply outline shapes of the particle, which indicate the direction and magnitude of the particle's initial and final momenta. So, that is the mv1 and mv2. So, ito. So, similar to the free body diagram, the impulse diagram is an outline shape of the particle showing all the impulses that act on the particle when it is located at some intermediate point along its path. So, due to the impulse or the impulse produced by the force at any time t, so ito yung naging direction niya. So, kapag pinagsama mo to, itong initial momentum diagram and itong impulse diagram, it will result in this diagram, final momentum diagram, which is somehow corrected naman, di ba? If this is going in this direction, and if na-applyan ng ganitong force, considering na yung force sa impulse is mas malaki, so ang mangyayari dyan, ito yung magiging final magnitude, or yung direction ng iyong body will go in this direction. Okay, so in each of the vectors in equation 15-3, so if it's going to resolve into its x and y and z component, so this can be rewritten considering this equation. So this three-scalar equation of linear impulse and momentum. So nangyari lang guys dito, you just need to get the x components of every force and velocity. Okay, so ito lang din naman yun. So nalagyan lang dito ng sub x, f sub x, and then velocity sub x. So when it is considering the y direction, so yun nga, y component lang din ng velocity and force. And same as for the velocity para sa z component. Okay, so next slide or next discussion will be for the procedure for analysis. So these are the step-by-step process on how you are going to solve problems for impulse and momentum. Okay, so what are the procedure for analysis? The principle of linear impulse and momentum is used to solve problems which involves the force, time, and velocity. So since these terms are involved in the formulation, for application it is suggested that the following procedure be used. So for free body diagram guys, we need to establish the x, y, and z inertial frame of reference and draw the particle's free body diagram in order to account for all the forces that produce impulses on the particle. So, ang lang naman yan, if yung force mo is going in the x direction, so dapat ganun din yung mangyayari sa inertial frame mo. So, yung mga x lang din yung kailangan natin i-consider. And so as for y and for z, so again, it's depend on the axis, na kino-consider natin, and at the same time yung mga forces available. The direction and sense of the particle's initial and final velocity should be established. And number 3, if a vector is unknown, assume that the sense of its components is in the direction of the positive inertial coordinate. So kapag yung vector mo daw is unknown, so it is always assumed in the positive inertial coordinate or the positive direction. Number 4, as an alternative procedure, draw the impulse and momentum diagram for the particles as discussed in reference to figure 15-3. Next, the principle of impulse and momentum. So guys, for number 1, in accordance with the established coordinate system, apply the principle of linear impulse and momentum. So again, ito nga yung formulation natin, which is mv1 plus the summation of integral of f dt with respect to time t1 and the upper limit of t2 is equals to mv2, or the final momentum. And if motion occurs in the xy plane, the two scalar components equation can be formulated by either resolving the vector components of f from the free body diagram or by using the data on the impulse and momentum diagram. Number 2, realize that every force acting on the particle's free body diagram will create an impulse, even though some of these forces will do no work. And last, forces that are function of time must be integrated to obtain the impulse. Graphically, the impulse is equal to the area under the force time curve. Okay guys, so para mas maunawaan siya, let's solve the following problems. Okay, so problem number 1. So a 1,500 Newton block is in contact with a level plane, whose coefficient of kinetic friction is 0.1. For letter A, if the block is acted upon a horizontal force of 250 Newton, what time will elapse before the block reaches a velocity of 14.5 meter per second, starting from rest? And letter B, if the 250 Newton force is then removed, so after daw niya ma-reach yung 14.5, tinanggal yung 250 Newton force. So ang tanong dito, how much longer will the block continue to move? Okay. So first, i-drawing muna natin siguro yung free body diagram and i-determine natin yung mga force na magko-contribute sa impulse niya. Okay? So, start. Okay, so first condition under letter A. So, yung block, kapag nag-drawing tayo ng free body diagram, so let's just say na when it reaches the 14.5 meter per second na velocity, it will reach this distance. Ano? Okay? So, ano nga bang hinahanap? Ano daw yung time before the block reaches a velocity of 14.5 starting from rest? So, from that term, we could say that yung initial velocity niya is 0 meter per second. And yung final velocity niya pagdating dito is 14.5 meter per second. So, ang tinatanong dyan is yung duration nung time, nung ma-reach na yung velocity na yan. So, ito yung unknown. Okay? So, ano yung time na yan? So, first, since nagbigay siya kasi ng coefficient of kinetic friction, meaning, with this force, with this 250 Newton force, this force causes the motion. And alam naman natin na yung frictional force is always opposite the direction. But what is the frictional force? So knowing that yung weight ng block is 1,500 Newton, ayan. So the normal force, so by free body diagram, summation of forces ng Y, by inspection alone, I could say that yung ating normal force is just equals to sa weight ng block na 1,500 Newton. Okay, so the frictional force is 0.1 of that, so that is just equals to 150 Newton. Okay, so I think kompleto na yung force na kakailangan natin sa impulse and momentum equation. So we can start now for letter A. So let's draw write the equation. So that is just the summation of forces and then multiply by the time. So yung time natin guys, yung initial time, hindi ko na isusulat since mag-start naman siya from rest and 0 time. So ang i-consider na lang natin is yung time na ma-reach niya yung 14.5 seconds. So sige, isulat na lang pala natin dito. So yung initial time dito, or t sub 0 is equals to 0. And then itong t, sabihin natin na hindi kasi ito pwedeng sabihin na final since meron pa tayong scenario B. So sabihin ko na lang as t sub a when it reaches this distance. Ayan. So is equals to ano nga to? MB. So M V2 minus V1. Okay? So with that equation, ito kasi, so force ito nga, itong time na to is t sub a minus t sub 0. Since yung t sub 0 mo is 0 na, so that is automatically f times t sub a. So ano yung mga forces that will cause a positive impulse? When we say positive impulse, parang sa work lang din, dapat yung direction niya is the same as do sa motion ng iyong body. So considering that, the only force that causes a positive impulse is 250. Okay? So multiply by time, yung unknown nga, yung hinahanap natin, which is t sub a. And then minus yung frictional force kasi opposing the direction. Minus 150 times t sub a is equals to the mass. So ang given sa iyo is in terms of weight. That's why we need to divide that by 9.81. And then multiply by the velocity 2, which is 14.5. Binigay naman sa problem. And then minus 0. So ang makukuha nating value, so 250 minus 150, so that is 100. So kung anong answer nito, i-divide lang natin guys ng 100. So let's just open our calculator. So that is, nasira na naman si calculator. Sorry, open ko lang guys saglit. Ayan. And then okay. So the equation will be 1,500 divided by 9.81 times 14.5 and then divided by 100. So what is time A? Ano ba yan? So that is 22.1713. So 22.1713 seconds. Okay, so for letter B guys, sabi nga dyan, if the 215 Newton force is then removed, so nawala na to, how much longer will it take the block to continue to move? Okay, so what will happen here guys is, tanggalin ko na lang to or ang gamitin ko na lang kulay ng ballpen. So mangyayari guys, yung final velocity kanina, yan na yung magiging initial velocity mo. Kasi mangyayari ngayon, ang tinatanong, ilang segundo pa daw yung kakailanganin bago bumalik or tumigil yung block na yan. So kapag ganun yung case, therefore, yung final velocity mo dito will be equals to 0 meter per second. Again, same weight pa lang na din naman ang block yan. Ang nangyari nga lang, itong 250 Newton load is 0 na siya or wala ka ng horizontal force. So since ito ay may movement pa din, ibig sabihin yan, may frictional force pa rin yan. Ano? Kasi gumagalaw pa rin siya technically kasi may velocity pa rin siya So ang mangyayari lang dito, yung value niya is sa palit na siya until it reaches a 0 velocity or it will come to a sudden stop. Okay, so frictional force is the same, 150 Newton. So apply again the same formula. So that is summation lang ng forces times T from which F, so ano ba to? So TA, so sabihin na lang natin dito as TB. Okay, so this is the unknown. So that is TB minus saan yun? Okay, so para dito kasi pwedeng dalawa yung mangyari. So ang gagawin ko na lang is TB minus TA. Okay? Or that is 22.1713 second. So ang mangyayari lang dito guys, sa makukuha nating second, yung makukuha nating time TB. So ang sabi kasi dito, how much longer? Ilang segundo pa ang kailangan niyang idagdag do sa 22.1713. Ang makukuha kasi nating time, kapag ganito yung ginawa natin is yung total time. So ibig sabihin, yung sagot na makukuha natin, isusubtract pa natin yung 22.1713. Since ang sinasabi kasi dito, ilang segundo pa yung kailangan. Or kung ayaw mong ganun, diretsyon niya, ang gawin mo, yung time natin dito, yung TA natin nakuha, since itong segment lang naman to ang pinag-uusapan, ilet mo na to as 0. Or ganito yung mangyayari sa kanya. 0 na agad yan. Ano? So, ayun lang naman yun. So, anyway, makita ko na lang din. So, equals to, sorry. So, 1,500 yung mass divided by 9.81. And then, yung final velocity natin, which is 0. So, minus the initial velocity na 14.5. So, yung force dito, guys, is yung ano na lang, frictional force. So, idiretso ko na guys dito, para at least may isa pa kasi tayong solution na gagawin. So, this will be, so since pakabila yan, so this is a negative force. Ayan. So, negative 150 times, ayan. So, ano bang gagawin natin? Alright, so pindutin na natin sa calculator. So, magiging positive siya. So, 1,500 times negative 14.5 divided by 9.81. And then, divide ko lang tong 150. So, that is negative. And then, transpose mo yung 22 plus magiging positive 0.1713. Okay. So, yung total time para ma-reach niya yung from initial point hanggang doon sa final location niya is 36.9521 seconds. Okay? Pero nga, ang tinatanong is how much longer? So, parang tinatanong ilan pa? Ilang segundo pa? Coming from time na 22.1713. Ilan pa yung dadagdag ko before ko ma-reach yung 0 na velocity ulit? So, if that is the case, how much longer? So, yung TB, minusan mo lang nung ano mo, TA. Or that is ano na lang. So, 36, ba't pa natin inad? So, minus 22.1713. Okay, so, 14.7808. 808. Ayan. So, this is the answer for letter B. Or, sabi ko nga guys, pwede kasi ang mangyari. Instead na ganito yung ginawa natin, pwede kasi ang ginawa, itong segment na lang na to. Kung saan parang nagsimula ulit ng panibagong condition na yung point na to is 0 second at yung point na to is yung unknown second. Or, ang mangyayari, ito is magiging TB minus 0. So, automatically, yung makukuha natin sagot is yung ano na, yung how much longer. So, ito agad yung makukuha natin. 14.780. So, try nyo na lang din pindutin, pero I assure you na ganun lang din yung lalabas na sagot. Alright, so guys, again, I'll give you 2 minutes to copy the solution. So, you may start copying. Alright guys, so let's proceed with the next problem. Alright guys, for problem number 2, so basahin natin. So determine the value of P that will give the system of blocks in the figure shown a leftward velocity of 20 feet per second. So 10 seconds after starting from rest. So mangyayari dito, itong system na to, makaka-attain kasi sila ng velocity na 20 feet per second daw. So yung time na yan, yung velocity niya yan is marireach nila 10 seconds after starting from rest. Again, itong starting from rest na to, ito yung keyword natin para malaman yung initial velocity, which is 0 feet per second. And from that, alam natin na yung initial velocity niya will be also equals to 0 second. Ito yung final time. Okay? So guys, just like do sa mga example pala natin sa work and energy. So alam naman kasi natin na may mga tension to. Ano? Kaso nga lang, since yan naman ay equilibrium or kasi yung tension dito, if consider mo siya, kung may tension ka papunta doon, mag-equal din naman kasi siya. Kasi may pakabila. So ito yung topic do sa work and energy na pinakita ko. Kung naaalala nyo pa na kahit hindi na natin consider yung mga tension. Okay? Do sa cable. Since maa-cancel din naman sila. So, ang i-consider natin dito is yung for this inclined block. Siyempre, sige, drawingan muna natin ng X and Y. Ayan. So, kapag ganyan may mga naka-inclined na block, aside from P, yung weight kasi niya mismo, which is 200, makaka-epekto kasi siya. Okay? Wala pa palang inclination. So, silipin ko lang dun sa figure. So, that is 30 degrees inclination, guys. Ito. So, 30 degrees din ito. So, meaning, yung component na to will also contribute to the force P to have its positive impulse o yung direction niya is the same as the force P. So, paano mo makukuha yung component na yan? So, that is 200. Tama ba? Sine of 30. And then, yung X component niya, or sorry, the Y component, or ito, so that is 200 cosine 30. So, kailangan na natin yan. Kailangan po natin yan para malaman natin yung normal force. Ano? Okay guys, so by inspection alone, we could say that yung normal force natin, when we take summation of forces of Y, so N is just equals to sa Y component nung 200 pound with respect to sa inclined surface. Okay, so that is 200 cosine 30. So now guys, if the motion of the body is all going to the left, so therefore, so kung pakaliwa yung mga forces o yung movement ng yung system, therefore, the frictional force is going the opposite direction. So the frictional force is going in this direction. So let's just name this as our block A, this one as our block B, and this one as our block C. So this is the frictional force for A, which is 0.2 of this normal force. So I think we can now proceed with the second block or the block B. So ganun lang ulit, gawa ka ng free body diagram mo. So disregarding the tension in the cable since maa-cancel out lang siya. So again, this is your Y and X. So what are the forces acting on this? So we have here 100 pound. So when you take summation of forces of Y, again, the normal force is always acting perpendicular with respect to the surface. So this is our NB, which is when you take summation of forces of Y, so NB is just equals to 100 pound. And since papunta nga sa kaliwayan, therefore, yung frictional force natin is going in this direction. Which is, that is 0.2 lang ng 100 or that is 20. Alright, so, ayan. So, sige, pindutin na lang din natin yung frictional force at A. So, open lang natin yung calcu. So, that is 200 cosine of 30. And then, 200 cosine of 30 times 0.2. So that is 34.6410. 34.6410 pound. Okay, so ano pa ba? So for block C, so we have here the weight just acting downward na 400 pound. So what other forces should we consider? Okay, so I think we need to draw the free body diagram independently, or i-redraw natin siya individually per free body diagram. So as I've said earlier, so sabi ko nga, kung ano yung value ng tension dito, yan lang din yung value ng tension dyan. But we need to consider pala yung tension since, as I've noticed, kapag gumawa ng free body diagram dito, we have here, so diba ito yung tension mo. So, eto. So, yung tension at C na yan, so when you take summation of forces of Y, eto kasi is 400. Ano? So, kung 400 yan, eto 400 lang din. This one is also tension C. So, this is also 400. This one is also 400. So, and so on. Ano? This one is also 400. Okay? So, kapag dinawin mo yung mga free body diagram bawat isa. So, una, meron ka dito, which is, yung mga forces mo are the following. So, we have here force P. And then, eto nga, you have here the weight of the block na 200. And its X component is 200 sine 30. The Y component is 200 cosine 30. And then, eto. So, you have here the 400. Etong tension. Okay? So, you have also the frictional force, which is going in this direction. Same direction as the tension na 400. So, that is 34.6410. And you have here the normal force na 200 cosine 30. Okay, so for the free body diagram 2 or free body diagram B, so you have here 100. You have an upward force of 100. So meron tayong frictional force dito, which is 20. And eto 400. And then dito is 400. So dito lang pala siya ma-cancel out. Not in the first block or for block A. And isunod na rin natin yung block C. So ano meron dito? So you have this here the tension in cable C, which is 400. You have here the weight of 400. So wala. Ano? So cancel lang din dito. So both in block B and block C, yung 400 tension in the cable will be disregarded since ma-cancel out din siya kasi meron kang 400 na paliwa, meron kang 400 na paanan. You have a 400 upward, you have a 400 downward. So magsisiro lang siya. Ano? But on block A, as you can see, so meron siyang value. Ano? So yung 400 pound will contribute to the negative impulse or pasalungat yung direction niya to the motion. Okay? So I hope we're clear on that. So now we can apply the equation for impulse and momentum. So again, that is just equals to the summation of the forces multiplied by the time is equals to mass times the velocity. Final velocity minus initial velocity. From which yung initial velocity natin or yung V sub O niyan is equals lang sa 0. Okay, so first, unahin natin yung impulse part. So let's start first with block A. So yung nag-contribute sa positive impulse natin is yung P kasi going in the direction, left direction, or going with the motion of the system. Yung force, kaya naging positive siya. So P multiplied by the time, which is 10 seconds. So P, I think it's better if we factor out the time T. Kasi, lahat naman ng force na yan, i-multiply natin ng 10. So P. So other than P, what other force contributes to the motion of the system? So itong X component ni ni weight, which is 200 sine 30. So plus 200 sine 30. So meron pa ba? I think wala na So next, dumako tayo sa block B. So this 400 contributes to the motion of the system. But there's another 400. Ba't ko ba dito tinuturo? Ito na nga pala yun. But there's also another 400 which is going to the other direction. So ito will be equals lang sa 0. So kung pag-addin mo yan, so kitang-kita na naman na magsi-0 siya. And so as for the block C, so wala nang force na i-consider dyan. So the only force that is remaining are the negative forces. Okay, so again, let's get back to block A. So ano ba yung nag-contribute to negative impulse? So we have the frictional force of 34. So that will be minus na. So 34.6410. And then, ano pa ba? So we have here the tension in the cable, so that is minus 400. And I think we're done with the first block. So next, for block B, so what force? So we have here 20, but it is going to the right. So that is going against the motion, so that is minus 20. And then I think, kompleto na tayo. So equals to the momentum. So let's start first with the first block. So that is 200. But again, it should be in mass. So in 200, para maging mass yan. So since ito is English, so we need to divide this by the gravitational acceleration. So anong i-divide natin siya sa saan? So ano nga pag-English? So we need to divide this by 32.2. Okay? So final velocity, ano yung final velocity natin dito? So ayun nga, naging 20 feet per second. So 20 minus 0. So no need to consider the 0. And then for the second block, so plus, we have 100. So divided by 32.2. May common term pala siya, no? I think it's much better if we make the equation like this. So since common yung final velocity mo na 20 and tsaka yung kanyang gravitational acceleration na 32.2, so ang gawin natin, i-factor out na lang natin siya. And yung nasa loob, yung itira natin sa loob ng equation, yung sa quantity, are the weight ng block. So that which is equals to 200 and then plus 100 and then plus 400. Alright. So I think we can now compute for the value of P. So input lang natin sa calculator. So mag-shift solve na lang. Sige, shift solve na lang tayo. So alpha x plus 200 sine 30 minus 34.6410 minus 400 minus 20, then close parentheses, equals to 20 divided by 32.2 times the quantity of 200 plus 100 and then plus 400. Then shift solve. So lagyan lang natin ng any positive value. So the answer here is 398.1193. 1193. So this is in pounds. Okay? So this is the final answer for problem number 2. So again guys, I'll give you 3 minutes to copy the solution. So you may start copying. Okay guys, so let's proceed with the next problem. Okay guys, so problem number 3. So this is a CE board, November 2000. So the 5 kilogram block at rest at time t is equals to 0. So, ayun nga, at rest at time 0. So the initial velocity there is 0 and the time is 0. Is acted on by a horizontal force that varies with time t as shown. Ayan. So varying force siya, hindi siya constant force. So when we say varying, so at any time t, hindi pare-pareho yung value ng kanyang force p. Maybe at the first 2 seconds, same lang na 20 yan. But pagdating niya ng 3 hanggang 4, naging ano na siya, changing na siya. So for letter A, which of the following gives the initial acceleration of the block? B, which of the following gives the velocity after 5 seconds? And C, which of the following gives the distance traveled after 5 seconds? Okay, so for the first question, which of the following gives the initial acceleration of the block? So to solve for that, initially, so ibig sabihin, at time 0, we all know that yung force acting on that body, the 5 kilogram block, is 20. Siguro, this is in Newton. Ano kasi kilogram? So, 20 Newton. So, as you can remember, sa ating first topic, yung law of force and acceleration, we have this formula na force is just equals to the mass times the acceleration. Actually, guys, ito kasing force diagram, pwede natin siya i-convert into its equivalent. Pwede natin yung paltan into its equivalent na acceleration diagram. So, ilagay ko na lang sa tabi yung value. Lagyan natin ng ganyan. Acceleration diagram. So, acceleration and dito is same lang din na time. Okay, so paano natin gagawin yun? So, by using this formula. So, if you're going to solve for the acceleration, that is just simply equals sa force over the mass. Or simply, in 20, just divide it by 5. So, this will be equals to 4. Or, this diagram, shape, same shape. So, this is 4 meter per second squared. So, same lang naman yan. Ayan. So, dito 4 meter per second. Sorry. So, this is 4 meter per second squared pa din. And then, pagdating niya dito, this will be 0 meter per second squared. So, malamang-lamang dito is 2 meter per second squared. Okay, so, I think we already answered the question for letter A. So, that is 4 meter per second squared. Dali lang, di ba? Next, which of the following gives the velocity after 5 seconds? Okay, so using this diagram, we can apply the equation for the impulse and momentum. So that is just summation of work. Summation of force, and then multiply by the time is equals to mass times the velocity. Final velocity minus initial velocity. But then again, we all know that yung initial velocity niya is equals to 0. So ito na lang yung consider natin. Okay? So, what will happen here? So first, unahin natin yung segment na to. Ano? So the first 2 seconds, the force acting on that is 20. Okay? And then multiply by 2 seconds. Ayan. So next will be for this part. So what shape is that? So that is a triangular shape. So that will be so since iisa lang naman yung force na yan, so that will be plus 1/2 of the base. So this is equivalent saan? Diba 2 seconds lang yan? So base na 2 times the height, which is equals to 4. Sorry. This should be not equals to 4 since force kaya pinag-uusapan. So ito is 20. This is supposed to be 20. Ayan. So, is equals to the mass, which is given sa problem na 5 times velocity. So, ito nga yung hinahanap. But guys, as you can see, itong portion na to is for the 4th seconds. So, at B sub 4. Okay? So, ang mako-compute natin dito is B sub 4 lang. Kasi itong itong diagram is acting only at the 4th seconds. So, sige, pindutin muna natin sa ALQ. So, that is 20 times 2 plus 20 divided by 5. So, this is 12 meter per second. But see, as you can see guys, do sa force time diagram, wala na kasing force na nag-act dito. So, ibig sabihin, ito, hindi na siya bibilis or babagal. Kasi constant na lang siya. Walang changes, walang increase, walang decrease. Therefore, the velocity at 5 second or the 5th second is just equals to the velocity at the 4th second, which is 12 meter per second. So this is the answer for letter B. And last, which of the following gives the distance traveled after 5 seconds? Okay. So the first thing that we need to do here is to determine the velocity siguro during this span, the first 2 seconds. Kasi nauna natin yung velocity niya at 4th second to 5th seconds. So, unahin natin or hanapin natin yung value ng velocity niya during the first 2 seconds. So, paano mo ba makukuha yun? Again, since constant lang naman yung force na yan, kung ano yung velocity niya dito, sa 1, sa 2 second, equals naman sila. So, again, by using the impulse momentum equation, so the equation will be 20 times 2. So, ang nangyari lang naman pala is nawala itong portion ng equation na to. So, is equals to mass and then yung velocity niya at 2 for the second. So, 40 divided by 5, 8. So, the velocity, second is 8 meter per second. Okay, so since we have now the velocity, again, eto is just the shape of or the force time diagram is ano lang din, yung kaya nga natin siya kinuha in terms of acceleration. Kasi 'di ba, kung maaalala niyo sa force diagram, ano nga sunod kay acceleration? 'Di ba, velocity? And after velocity comes the displacement or yung S. Okay, so naka-base tayo kasi sa shape na tong diagram na to. So, i-lower ko lang guys yung ano natin. Ayan. So, i-offset ko na lang to ng konti para at least mas kita. Ayan. So, i-plot lang natin. So again, itong velocity dito is just the same as the velocity for the 0 and 1st second. So ito siya. The diagram will start here. So sorry. Sabi nga pala dyan, the velocity at 0 seconds. So it starts from rest. So the initial velocity here is 0 seconds. Okay? So, iba pala yung value ng velocity niya at the first seconds. So, coming from 0, so since this is a 0-degree curve, so mangyayari, ayan, magiging first degree curve siya. Okay? So, this is 8. So, malamang-lamang, etong velocity niya dito is 4 meter per second. So, again, this is for the velocity, which is in meter per second. So, balik tayo sa previous topic natin, and the x will be the time. So, that is in seconds. And the next, Since ang shape nito is ganito, so pasok ulit tayo sa maximum minimum. So this is the maximum, this is the minimum value. Ayan, pag-connect mo lang na ganyan. Alright. So magiging 12 meter per second. And since yung velocity niya, walang force na nag-apply, so ibig sabihin, straight lang yan. So the velocity at 5th second is the same. Alright. So this is a first degree, so ito yung magiging second degree, or the shape of a parabola. Okay, so ito yung shaded area. So how can we solve for the displacement? Ano bang hinahanap? Distance traveled after 5 seconds. So we need to get the area. Itong area nito. Ano? So to get that, the S at the 5th seconds is equals lang. So let's start with this one. So again, i-lower ko lang yung ating diagram. Ayan. Siguro na pwede na natin siya idiretso dito. This is the shape of a triangle lang naman. So that will be 1/2 of first, ano ba daw? 1, 2. So 0, 1, 2, 4, 5. Okay? So that is just equals to 1/2 of the base na 2 and the height of 8. Okay, so coming from minimum, so this is minimum, maximum, minimum, maximum. So plot mo lang yan. And then plus, since nasa ibabaw siya, so ito, di ba ito is makaka-form ng shape ng rectangle or square. So this is 8. So kung 8 to, therefore, etong height ng iyong parabola or spandrel na yan will be 4. Okay? And yung base natin will be equals to 2. So bakit naging 2? So 4 minus 2. So that is the base of the rectangle. So 2, unahin muna natin to, yung shape ng rectangle na yan. So 2 multiplied by 8. And then plus. So again, paano ngayon makukuha yung area nito? So di ba kung itong shaded area, di ba yan ay magiging 1 over n plus 1. So, ang degree niya is second degree, so or that will be 1/3. So, kung 1/3 yan, therefore, ito, this is 2/3 of base times height. Tama? So, plus 2 over 3 of the base, which is 2, times the height of 12 minus 8, which is equals nga sa 4. Alright, so, and last, will be the area of this to get the displacement at 5th second, or the distance traveled. So 4 minus 5, so this is 1, and the height is 12, so plus 12 times 1. Alright, so what is the distance traveled after 5 seconds? So ano ba yan? Minimum, maximum. So coming from second degree, magiging third degree. And then, ayan. So this is first degree. So, ito yung S5 natin, or the distance traveled after 5 seconds. Pero ito na lang, pindot na lang natin itong naka-input sa So, 8, cancel ko na to. So, 8 plus 2 times 8 plus 2 divided by 3 times 2 times 4, and then plus 12 times 1. So, that is 41.3333. Ayan. So, correct naman yung nakuha natin sa sagot. So, 41.3333 meters. Alright. So, you may start copying, but actually, pwede nga hindi na tayo gumamit ito Pwede kasi mangyari, diretso na tayo ng concept nung yung nauna nating topic, yung relationship nitong AB S diagram or yung parang shear and moment. Ano nga topic ito? Kalimutan na gan. So this is under the category of ano ang tawag sa topic? Yon, under motion curve. Ano? So pwedeng idiniretso na natin sa motion curve. So nakikita yung relationship ng dalawa. So eto, gumamit tayo ng impulse and momentum to get the value using yung summation nga ng impulse na force times time, and then yung momentum na mass times the velocity. So nakapagpalabas tayo ng mga value ng velocity niya. Ayan. Or the alternative solution, so yung force nga, i-convert ko using the law of force and acceleration or the Newton's second law of motion. So nahanap ko yung acceleration niya considering yung force. Ayan. So kinonvert ko lang siya using F is equals to M times A. Ayan. So after getting the acceleration, ayan. Ano mo lang, area lang nito 4 times 2. So 8. And then 0 maging first degree. So ayun. Okay? Anyway, please copy. So i-zoom out ko na lang para hagip na yun sa pababa. I'll give you 2 minutes. 3 minutes siguro kasi mas mahaba. Okay guys, so let's proceed with the next problem.